Hi, my name is Moinul Khan. I'm the co-founder and CEO of Aurascape. Today, I'm going to be focusing on data security for AI. As you probably know, when your users, your employees are consuming all kinds of AI tools, generative AI, embedded AI, agentic AI, the number one concern for CISO and network security team is the data loss. Through prompt query and responses, a lot of sensitive data, intellectual property that are going out. So again, the way we see the problem statement here is when people are thinking about consuming more and more AI, data security concern is the biggest risks for organizations. So let's dig deeper into data security for AI. Before I do that, first, let's talk about what are some of the fundamental problems that we have seen in general in the data security space over the last 25 years. And, especially with a lot of DLP tools out there, a lot of DSPM tools out there, the SSE, firewall, everything has embedded data loss prevention. But over the last 25 years, organizations and customers, the consumer, for these DLP products highlighted a lot of problems that hasn't been resolved. So, from problem perspective, the number one complaint is about false positive. Significant amount of false positive comes through these DLP tools because of the regular expression and regular expression-based engine. A 9-digit number is a candidate. Any 9-digit number is a candidate for a social security number. Any 16-digit number, gets triggered as a credit card number, and so on and so forth. And if you are one of those consumer of DLP, you know that a bunch of fingers have been burned in the past. The second is noise. Sometimes the detection is correct; it is the right SSN or a CCN number, but the problem is these tools are generating a tremendous amount of noise that are not actionable. An example could be if PII data like 5 employees' first name and last name show up in a Word document versus the same information show up in a termination document. These are two very different contexts, but the DLP is triggering alerts because the DLP engine matched someone's first name and last name. The third problem in the traditional DLP world is all the DLP primarily has been done on file upload and download. And this has worked for SaaS-based services. This has worked for web application. But when you think about AI, this traditional DLP engine no longer is relevant because your sensitive data, your intellectual property, most likely is going out the door through a prompt query and responses, not through file upload. And then the last problem that we have seen in the DLP world is the architectural problem. You are going to find tons of out-of-band CASB tools. You are going to find a lot of DSPM tools, DLP products that are sitting on the side. They're not inline. They're not prevention focused. These tools were developed using API. And at the end of the day, when it's time to secure your data, everything is happening after the fact, and because of that, these tools are not very effective. So, at Aurascape, when we started thinking about these issues that we have seen based on our experience over the last 25 years, we wanted to tackle all of these problems early on, so that the data security that we do for AI makes actual sense and it is very effective. So the way we solve that problem is first, if you think about how do we, take care of the false positive issue, we sort of like flip the logic in our data classification engine. So instead of heavily depending on regex, the first thing we try to use is heavy amount of ML. We have used a lot of sophisticated languages like stemming and lemmatization and term frequencies and clustering. So when we start looking at a conversation that is happening, within the AI tool, the first, again, step number one is use ML, try to identify that conversation at a higher level. And then once we identify a topic, it could be a conversation related to finance or HR, or it could be a healthcare related conversation, M&A related conversation. That's our ML layer, where we are recognizing the conversation at a higher level. Next, we look at the subcategories, right? So if a conversation is happening about M&A, within M&A, there could be a different type of M&A conversation, right? Some conversation will have pre-deal content. Some conversation will have post-transaction content. And for this middle layer, we heavily utilize large language model and small language models. And by doing so, we were able to build, out of the box, we were able to build 600 plus subcategories, right? So again, how do you go granular from ML by shifting to LLM and SLM? And then at the third layer, we use regex, right? Because at the end of the day, customers are interested to protect a PCI ID or PII related identification, or they're looking for a dictionary that is related to PHI. But then with this 3 layer of classification, we are able to be we are able to support a high level of accuracy. So just to give you an example, if a conversation is going on, first we are going to say, oh, I'm looking at a conversation that looks like finance bank related conversation. Within this query and response, then I'm looking at a payslip. And then within that payslip, I'm looking at someone's social security number. So the identifying this conversation as a finance and bank related conversation is ML. The subcategory, we are saying it's a payslip. And then within payslip, using regex, we are looking for a social security number. And most likely now, this detection of social security number will be very accurate because we curated the content. So that's how we reduce false positive. The second is context. Again, the context is very important. And the way we look at content is we are one of the only vendors in the industry and inline security stack that can capture every single AI conversation word by word on clear text. So when we actually look at a full conversation and not just metadata, we know exactly what the user intention is. If a software developer is going to ChatGPT and says, I want to learn Python, give me sample source code, even though the source code shows up on the wire, we don't try to generate an alert because it's harmless. But the same developer, if they cut and paste some content from your code repository and saying, fix my source code, then that's a problem. So by bringing this full context, full intention, we reduce the noise significantly. And then the third one is, as I said, the file-based DLP makes no sense for AI because most of your sensitive data is going through a prompt query and prompt response. So while we do enforce all these policies using ML, SLM, and LLM for file uploads, but our fundamental focus is do the data classification and data security for the conversation, for prompt query and responses, and we make sure that we are looking at both inbound and outbound. In other words, not only we are looking at what the queries are going out, but we are also capturing all the responses, and we are applying the same policy. And then the fourth, this is very fundamental to Aurascape. We didn't want to build a company which is API based and just giving you visibility. We are full inline. We are an inline proxy, forward proxy that is sitting between your users and all these AI tools the users are using for your private applications, for your AI agents, for your MCP clients. We are a full MCP proxy. We are an MCP gateway. Again, we are full inline. We provide real-time visibility and real-time enforcement, and we try to avoid after-the-fact actions. That's exactly how we see how the data security is evolving over the years, and then the way we built it, it is absolutely relevant for the AI era. Thank you.